Well, okay, let's go ahead and start. We may have some people walk in. In the meantime, just to let you know, my name's Lori Jolstrom. I'm from Intel, and I do a lot of the UEFI EDK2 training. This particular training we actually did last year, working with the driver wizard. That's what we're going to do in the labs today. So if you were here last year, it'll be a little bit of review. And maybe that's the only time you used it, so this will be another reiteration of it, but maybe you'll learn some more things as we go through. We try to improve on it. You saw I had actually a bug in the code, so I actually fixed that in the meantime. So those kinds of things come up, and so hopefully now it's working. So a couple of things. Everybody's in front of a workstation, I hope, because that's where all the code's going to be. We're going to work off the workstation. If you look in the C drive, if you want to take the lab and so forth home with you, if you got a thumb drive, you can copy. There's a zip file you can copy to, and also the labs and or the presentations and so forth. Meanwhile, if you look at your desktop and your workstation, we have a couple of things. We've got the presentations, and on the there's a share here where I put the lab guide that we're going to work with. The presentations today, we're going to go over the wizard, the driver wizard lab. So we'll be looking at that, what that's going to be doing for us. So if you want to follow along the presentation, it's going to be just a little bit of a review about what a driver is and so forth, and then we're going to go right into the lab with working with the driver wizard. And then the lab guide, I know I have a PDF of it. I also have the Word document. Sometimes when we're doing the copy, this is not a C class, so I'm not going to teach you about writing in C. I'm not also going to try to teach you about typing. So a lot of the code is in the lab guide, so you can copy and paste. I find that it's easier to copy and paste from the Word doc as opposed to the PDF. PDF is for publishing on the web and so forth, but for everybody in here, you can use this Word doc to take it from. What else we have? We're going to be using Visual Studio 2010 today, so that's on the workstations. It's all installed. I think when you load it for the first time, it may ask you a question of what you want to work in. Choose C++, so be aware of that. Also, I'm going to be when we go in the labs, it's going to be go to your Visual Studio command box. So here you already have it up here in this workstation. It's already ready for you. Also installed on the workstation is the wizard itself. If you take the zip home, it is included in that zip. It's also included on the SourceForge, tanocore.org, if you want to download it. Everything, all the source code is on tanocore.org. The solutions, except for the new labs, are just on the zip. So you'll have those. Eventually, we'll put it on the UEFI events web page under the learning page. But for today, you can take home the zip. And then also, what we're going to be working with is C: under FW. So we're going to have the presentations, we're going to have the source code there, and all the lab material, solutions for all the lab materials under there. And so what that looks like, if you look under that directory, we have the presentations. So you'll see another presentation called Shell. We did that last year. We did that similar presentation. There may be some improvements on it, going through the steps of looking at the UEFI shell. So if you want to look at that, you feel free. And if you have the lab material, you can walk through with the lab that's included. The lab's the same, so you can look at that as well. The EDK2, this is straight from SourceForge. A month or so ago, I went and downloaded the EDK2 and put it up, made sure all the labs worked, and so that's what we're going to work with today. So it's all the open source code. Driver wizard, so that's the install for the driver wizard. And again, that's already installed for you. So you can see if you want to reinstall it, if you want to take it and install it on your laptop or whatever. Lab sample code. So this is the solutions. Every single lab will have a solution at the iteration that we're working on. So that if you make a typo or something, you don't have to go back and try and figure out where the typo was. Or if you want to, it's a good debug exercise if you want to do that. But the solutions are there so you can copy it into the directory or the iteration that we're working on for that lab. And then documentation, there's some what we call the helper chem files. I'm going to allude to them in some of the presentations because these are going to help us with writing code and looking up things like libraries that you might want to call, functions you want to call. So that's included as well as along with some of this. All the information, as I said, is downloadable from the tianacore.org or the SourceForge website. So I just packaged it up into the training material for you for this training, and also what we have is our 3-day training as well. Some other information, resources. Of course, we have our Intel community website at the intel.com UDK. It's our open or our facing external website, specifications, and our TianaCore website. So I probably all are familiar with that, and my email, of course. And if you may have noticed on your workstations, there's already an icon to go to the tianacore.org website. There's also one for the UEFI website, and also one for the one I just showed you, the Intel one. A lot of times, if you want to ask questions or are looking for things, this Tiano, if you're not aware of it, we have some frequently asked questions. We also have a mailing list. So probably everybody in here might be familiar with this and looking at that. It's very useful information. You can search on it, search on the mailing list, and so forth. Any questions before we get started? Okay, so I'm going to go ahead and start. And we're going to start on the presentation. It's labeled Lesson 8 because this is right from our 3-day training. So this is actually the Lesson 8 that we go through, is doing this web, this wizard lab. So we go here. And I just put on it, it's pretty much the same thing, Summer Summit. I just label it that so I know what it's for. So what do we want to get out of this? This wizard is going to give us a template for a driver, a UEFI driver. So once we're done, we're going to actually have code for a UEFI driver. And it will be loadable. We're going to test it in the NT32 emulation. So we can look at it, see what we can do with it. We have a template, so now we can just start porting code with this template to do different things. So we'll look at some portings. And we only have an hour and a half, 2 hours here. So we're not going to go through the whole thing if you were writing a real driver. But we'll see the idea of, well, how do we port it for like the supported and start functions and so forth. So we'll look at some of that detail. A little bit of driver review. So if you've been writing drivers, this may be a review. So what is a driver? So it's just a loadable image. So we took some C code, wrote some C code, compiled it. We got an executable out of that, and we converted that to a UEFI image. It's a loadable image, so now it's a loadable image. We can load it with some kind of loadable image for UEFI. A driver may produce and consume protocols. Typically, a driver will produce protocols so that later on down the road, somebody can use those protocols. It's used to support bus hierarchies, so we can support things like PCI, USB, and so forth. We want to hook in. It's kind of a hook into things that are down the road here. So that's what we're going to do. One of the things with UEFI, we have something called the driver binding protocol. The driver binding protocol is that protocol that's going to say, hey, I'm going to support some piece of hardware out there. If the system says it needs a driver for it, I'm going to raise my hand and say I support it. So we do that with something called the driver binding protocol. So the driver binding protocol is going to be our kind of hook into the system to support underlying hardware. And the idea is we want to match the hardware with some driver. And as you may know, that in UEFI we have things that are devices, and we have drivers to support those devices. So the devices, we want to match a device with some sort of driver. So this is what we're kind of trying to do here with our UEFI drivers. where does it fit in the underlying or our picture here of booting up a system? So if you're familiar with the UEFI and how we start from the reset vector and go up through the process and boot process and get to our OS, well, some point along the line is we're going to start with UEFI drivers. We have our SEC, our PEI, which is very close to the platform, the underlying platform code. So it's very specific to the chipset, the processor, and so forth, that it's coming up in UEFI. Then we get to the Dixie code, which is the driver execution environment. And this has got something called dispatcher that's going to go through and start dispatching the drivers. It will dispatch Dixie drivers, which are sometimes platform specific, don't have to be, but probably more platform specific. And then we get to something called the UEFI drivers, which are not so platform specific. They could be these add-in cards, third-party cards that is added into the system. And they are going to follow some of the UEFI protocols so that they can be added into the system. So they fit kind of in the later stage of the Dixie driver execution environment. So first, the Dixie driver execution environment, or Dixie, is going to dispatch all the Dixie drivers. And then after all the Dixie drivers, it will dispatch the UEFI drivers. So that's where it fits into the boot sequence, is in this stage here. Before we get to the BDS stage and after all the Dixie drivers get dispatched. Where do UEFI drivers fit in what we call this big H? So we can think of this as the underlining of setting up the protocols. We've got the PEI protocols, which is going to be our chipset, our memory reference code. These are going to be modules that get put into there. And then our UEFI drivers are going to be sitting in kind of already established, know about the, or may not necessarily know about the underlying hardware. If we look at the dispatcher when it gets called, so the dispatcher is going to be this UEFI loader that's going to go out and start loading different UEFI drivers. So UEFI driver is going to have an entry point. An entry point is the start of that driver. It's the very initial start. That's what the dispatcher is going to call, is the init, or the entry point of your code. So this entry point is going to say, okay, what drivers am I going to, or what protocols am I going to produce? What protocols am I going to consume? So it has an initialization stage that goes out here and says, oh, I'm going to produce protocol 1, and that's going to be some protocol that's UEFI in the UEFI spec, protocol 2, and so forth. And it does this through some kind of library call that we call an install protocol. So it installs those protocols. Those protocols are now sitting out there in memory. The initialization just installs the protocol and exits, leaving that protocol in memory. So now that's in memory. Anything in the system can go now look and say, oh, this is in memory. I can go in and access those particular protocols. So those will be in memory. We have this handle database. And as you may know, in UEFI, everything gets a handle. Image, driver devices, everything gets a handle. So all of those protocols that driver established are going to have a handle. So let's look at how this gets established here and the construction of that. We have our driver, and it has its init point and an init code. And it's going to want to set up to have its protocol interface so that it can manage those underlying hardwares that it needs to manage. So it's going to call something called install protocol. And again, if you want to look up at the different protocols, those helper files that I mentioned, the .chm, you can look at that, and one of them may be an install protocol interface of some sort. There's install multiple protocol interfaces. There's install binding protocol interface. So there's different forms of this that are library calls that you can use for installing these protocols. So we want to make this call so that this driver installs its protocols. it installs it, and when it does the install, it gets established into the handle database. So now anything else in the system can go and search for the installed protocol looking into the handle database. And there's likewise library calls called locate protocol and so forth that you can now look up the various protocols to go and search through the handle database to find the protocols that it needs to call. So invoking one of these protocol services, you do a locate protocol. It finds the protocol that you need to look via the GUID, since you're always working from a GUID. It finds the GUID, or finds the protocol in the handle database, and then can go in and access that protocol that the driver established through the install interface. So you can think of a UEFI driver as inserting some interface in between that goes and manages some underlying hardware. And it's going to manage it with its own code or own driver. Excuse me. And then it might go on to the next driver. The driver binding protocol is one of the key protocols for our UEFI drivers. This is what it's going to do for supporting that. We have a supported section. This is just a snippet of code that's going to go out and say, yes, I support this device. No, I don't support this device. So it's going to get past some kind of controller that it needs to decide if it's going to support or not. You have the start that if it did support that particular device, it needs to set up for that, which means it needs to install a child handle or install another protocol, depending on what it's doing. So it's going to install other things to support the particular device that it needs to manage. Then you have the stop protocol or stop function, which is just going to be the opposite of the start. So it's going to do the uninstall of child handles, devices, protocols, or whatever that start established. So that's kind of the main points of our UEFI driver that we're going to look at. We have some examples out in EDK2 that are available. And I just took this SCSI disk because it's a real simple example. It's off the PCI bus. So you can see it looking at the PCI protocol, and it's going to hook into that. And if we look at things like the INF for that, so if I pull that up, you can see that we have an entry point. So this is actually going to be a function in our code, in our C code, called initialize SCSI disk. That's the entry point to our code, and it will just start executing at that point. We see that it's a module type of UEFI driver. We have a GUID, and we're going to get a base name there of SCSI disk. And then just looking at some of the global protocols that this is going to be using, so it's going to consume these protocols. It's going to need these protocols. So we got disk I/O, we've got block I/O, SCSI pass-through protocol, and extended SCSI pass-through protocol. So that's our INF. If we look at our H file, I go to the H file. Oops, there. Our H file is going to be where we're going to have our includes. We're also going to have our data structures. So we'll have our private data structure area that will be part of our driver. Any global variables we have, and so forth, and any other things. And then our what do you call it? It's prototyping, function prototypes. Then lastly, our C code itself. And what we want to point out in our C code, so we have our include. We've got the binding protocol. So here we're going to have a function called SCSI driver binding supported, and the same thing start, and the same thing stop. The version, and then a couple other pointers there. That's got the SCSI disk info protocol. And our entry point, initialize SCSI disk. This is the same one that we had in our INF file. So this would be our entry point. And you see all it does is it installs the driver binding protocol and our component name protocol. So this is one of those multiple install library functions. Install those. When it does the install, we give it the name, image handle. This is of itself, the one that got included to it, and the other two ones. So we got the component name and component name 2 protocols. So any questions about that so far? Okay. So let's talk about creating this UEFI driver with this driver wizard. So I'll just give a little bit of a prelude to this before we go to the lab. So we have this wizard. It's a tool that was done by some of our engineers at Intel, contributed. It's on tianacore.org, so you can download it. It's based on the driver writer's guide. Again, this is another guide. We're just going to touch on the surface of writing a driver today. If you're going into writing an actual driver, you want to download this driver writer's guide as well to look at that, to go in deeper. Some other requirements. We have some things for EDK2 dependencies, base tools, MDE package, and the module package. And actually for our UDK 2010 from tianacore.org, Brian puts together a release of that. So you don't have to download the whole EDK2 release. You can download this, which has those packages in it. And we're just going to use we're just going to use the lab setup that we have on our workstations. What do we want for this particular driver that we're going to work on today? So we're going to just do a device driver. We're going to have a particular version. This is 2.3.1, since that's the code implementation that we have today. We don't have 2.4 yet, so 2.3.1 was the last we have. We're going to make an unloadable driver. So these are requirements that we're going to make on our driver we're going to write today. We want it to support IE32 and x64 processors. We want it to support the component name. So we want a component name so we can give it a user identifiable name when we query the system for that driver. It's going to have the test console device protocol. And we also want to set up, now tomorrow we're going to do HII. So we're going to actually do the setup for setting up for doing HII, and tomorrow we'll continue on adding to this same driver using HII. But for today, we're going to spend time today working on the supported and the start and the stop functions. So we're going to get a template when we get done here. It's going to have the entry point. So it'll have the driver's entry point and basic driver libraries and headers and so forth. So you can actually, we'll see that we can put this in our NT32, compile it, and we'll see our driver. We don't actually have to write any C code with this wizard to get the template. Once we start porting, now we have to write C code. So we're going to write some C code today, but to do the wizard, you don't have to write any C code. We have the skeletons for driver functions. So you saw that I had a couple of HII protocols we'll have in there. So there'll be a skeleton for that. There'll be the start, the stop, and the supported. There'll be functions for that. But they're not going to do anything. they're just going to be returning either unsupported or device error, depending on what function it's satisfying. We just want it to work as a UEFI driver and have the template for a UEFI driver, which will have our basic functionality for it. So with that, let's go ahead and start on our workstations and get to the labs. So what you want to do is open up the guide. So I think I can go put this up here at this point. And go to lesson 8. So if you open up, and like I said, I'm going to suggest you open up the .doc. Everybody's got Outlook, or not Outlook, Word on your workstation, so we don't have to worry about that today. So go ahead and open up the Word doc and go to lesson 8. We're going to start out with. And a couple of things are already done for us, so we don't have to worry about. We already have our Visual Studio set up, and that was that icon that I showed you. So that should be set up. So if you want to go to that for the first time, I'm going to do this. I'll open up mine. So you get, once you open it, you'll get a like this. And we already have installed the wizard. So actually, we're going to skip down to step 11 here. But like I said, if you're taking home this and you want to put this on your laptop or your workstation at home, you might have to go through these steps first. For our workstations, we should be able to go right to step 11. And we're going to go ahead and open the UEFI wizard. And it comes up with just a blank screen. And what we're going to do is define our workspace. And for today, we're going to do C:, your workstation, and FW, E to K2. And that's going to be our workspace. And next, we're going to go to File, and we're going to select New UEFI Driver. Now, one thing we want to make sure, and you can put in any name, but if you want to follow along with the guide and so forth, we called it My Wizard Driver with a capital M, capital W, capital D, and all the rest lowercase. Things are case sensitive, just like in C, so be aware of that. And I will warn you, just type in the name on this line and not on this driver name line, because otherwise it will copy and you'll get an error. You will need to put a version in here. So you'll need to put a version in here. It also generated a GUID for us. So we don't have to go out and find a GUID or put it right in there. So we got a GUID in there. We're going to have it's going to be a UEFI device driver. And you can put a version in here. Now, these are not the same. This one goes in your INF. This one gets put into your binding protocol. So be aware that they're different. And maybe one is for source control, like in the INF. The other one is for you need to update your driver that you're giving out to your customers. Next, in our features, we want to do unloadable. That was one of our requirements. It's going to be a supported EFI driver version. And we're going to do 2001F, and that corresponds to 231. I think the 31 is our 1F. If you translate the hexadecimal to those 2 decimal numbers. I don't know what the 2.4 is going to be. Maybe somebody else, does anybody in here know what 2.4 will translate? 20020? Or, so that's a, then HII packages. So this is going to set up for the next lab for tomorrow to doing HII. So we're going to get HII packages and so forth. So one of the things with EDK2, the tools does the packages for HII, and the driver wizard sets us up for doing that. So it's going to set up the template again, just like it's going to do for the start, stop, and supported. It did the same for HII. We said we wanted to do IA32 and X64. I'm going to set up mine here. Oh, also, you may have noticed that this was grayed out until you clicked that. So that was doing a smart thing there. I'm going to create one at the same time. If we go on to the next menu, we've got component name, 2, component name. So you can select both of those. So component name 2, so that was added to the spec. So that instead of redoing component name, the burst protocol, they made it a component name 2 spec. And that has to do with the these 2 things here. The way the localization is done. So it's a 2x2 rather than a 3 code language. And component name without the 2 is the 3. And component name 2 is the 2x3, or 2x2, or 2x3, depending. So that's the references to that. And then also check for HII packages and forms. Then we want it to be a PCI device, so you shouldn't have to change anything there. So click Next. And then finally, we want it to do text console producing a simple text output protocol. Select that. And when we're done, you can click Finished. And what you should get is a bunch of files that get created in our My Wizard Driver subdirectory. So all of this is going to be a template for us. We can now compile this code and check it out. And that's exactly what we're going to do next. Now, a couple of things with EDK2 is you can do a whole project, which is what we're going to do with NT32, or you could just do your driver by itself. So if you're writing a driver and you're going to a different target machine and you don't want to have to recompile an entire project, you can do the standalone method here. Since we're going to do NT32, we're going to do this one. So we're going to actually put our name of our INF in the NT32 DSC file. So the next step is we need to update our NT32. So now this is where we're on these workstations. Notepad works pretty good. So you can use Notepad to edit this. And you want to, okay, you should see this. If you scroll down, is build new shell. You should see that equal to true, hopefully. And what we want to do is we want to insert My Wizard Driver, the INF, and make sure your caps and so forth, your case sensitivity is correct. you're going to insert this in the components section of your NT32 DSC file. So it can be anywhere. Now be aware that on NT32 it's just 32-bit. If you were doing this on a real target system and you had a 32-bit and then a 64-bit component, make sure you do it in the right spot. So typically if it was that way, you want to go into the 64-bit component part. For today, it's okay to just put it up at the 32-bit. So we'll go ahead and add that to our NT32. And then save your NT32. Now once we do this, we're ready to start building. So you want to open up your Visual Studio command prompt. So that's the one that's on your workstation, the black square thing. It'll be your Visual Studio command prompt. You want to go to the directory C:/FWEDK2. And you want to type in, now since we're going to this the very first time, we're going the very first time to our Visual Studio command prompt, we're going to need to do EDK setup. And this is going to set up our environment for this session of the Visual Studio command prompt. Anytime you exit and come back in, you're going to need to do EDK setup again. So do EDK setup. Now, hopefully everybody's workstation's all set up correctly. I checked it out yesterday on one and somebody else did on another, but hopefully at this point we should be able to type the build command and it should be able to build in our new driver that you just created with the wizard. So it'll take a minute for everybody to do that. I'm going to do it on my line up here. Yes. Okay, scroll down. It's okay. This is okay. Yeah, you want to add this line, not to that file. If we scroll back up, you want to actually add that to this file, NT32. So yeah, that gets added, and it gets added somewhere in the components section. Yeah, so edit the NT32 package DSC file, and that should be in our C:/FWEDK2 NT32 package directory. And after you do the build, anybody have any problems building? It built? Oh, that's good. That's really good. Okay. So we want to test it now. We got a driver. We want to test it. So you can do a build run. So type build run in your Visual Studio command window. And right away, you're going to get the NT32 emulation. So here I'm going to show you. I'm going to do a oh yeah. And how many have a question now when they did that? Why are the two windows? Yeah, okay. Yeah, so normally we did the shell class first, but since we didn't do this time around. You type in the NT32 emulation, we actually have the capability of doing multiple consoles. And the NT32 emulation has a default of 2 output consoles. And so it puts out there 2 of them for us. There's a PCD value that sets that up as 2. We can set that up for multiple ones. It's going to only display up there 2 at a time, though. But so we actually have to change the code to do multiple ones. But yeah, for our NT32, you get 2 windows. And I always like to say, because I'm usually training with NT32, I can now have a window here, and you can not have to type over my shoulder like that. So you got the window, you got our Visual Studio or our NT32 up. Now we want to go to check out our driver. Now one of the things is we have to be in a file system. So our NT32 emulation sets up a couple of file systems. And again, this is through a PCD value. We set up a kind of a pseudo file system. It's just directories on our drive, our hard drive. So FS0 is a pseudo file system. So I should have a file called MyWizard Driver EFI, and you can see that it was just made today, just a couple minutes ago. I can load that with the load command. So I'm going to load it. And I'm going to load MyWizard Driver, and there it goes ahead and loads. Go through our lab session here and see what we did. We load it. You see that it loads okay. And then you can do drivers. Type in drivers. And at the end of drivers, what you should see is a listing for your driver, and it should have a handle there. And I don't know what it is on your 79 on the workstations. Okay, it might be something different. On my laptop, it turns up to be 78, 79, depends on what is hooked in there. And you can do further information with that particular driver using the driver handles with a DH command and -D, and that gives you more information about that particular driver. And we're using shell 2 here, so if you're familiar with shell 1 versus shell 2, it's slightly different formats for different things. It tells you what protocols it is consuming and producing. So we've got component name 2, driver binding. One thing the shell doesn't know about, I think that's the text one. And where it's located, you have it in the default directory, and so forth. So it's just some things. It doesn't manage anything yet, so there's things there. So we have our driver. You can try the unload. So you want to unload whatever device handle that it got. So in the case of if it got 79, you want to do unload space 79, and it'll ask you the question of, are you sure you want to unload? And hopefully it will just return. And then if you type drivers again, you should see it not be there. And we're going to actually port the unload and stop functions in another lab here. So that's it. We didn't write any C code. We had to update one file to get it to build for our NT32 emulation. And now we have a template driver. We need to port it, though. Right now, it doesn't do anything. It just loads and doesn't do anything. It's got the code there in place, but we're not really doing anything with it yet. So what we want to start doing is porting this. So go ahead and type reset, and that's going to close your 2 NT32 emulation windows for you. I don't want to type reset in my document there. And we're going to continue on to add to this. The first thing we're going to do is something very simple. We're going to edit some C code. So this may be pulling up your Visual Studio for the very first time on your workstations. So in your MyWizard driver directory, there's a file called componentname.c. Go ahead and double click on it, and you should be it should be pulling up Visual Studio, and it should be pulling up Visual Studio for the first time. Select C++, and you should get that file in your window for your C++ or C code. Wizard driver, component name. And we're going to just do something very simple. We're going to go ahead and edit just the name. And you can see now that we had component name and component name 2. So we wanted both protocols. Now it's the underlying system that this driver is on, whether it's going to do component name or component name 2. Your driver is going to support both. So it doesn't matter what the underlying system that it gets installed in. It does both, so if it's a component name only, so it didn't support component name 2 yet, you'll have it already there for supporting both of those. And it does this for this data structure here. We're going to change that. And a little bit of notation here. It's a car16, which means it's a Unicode type. UEFI works in Unicode, so that means it's a character. It's a 16-byte character, or 16. I should say 16-bit character. Yeah. Yeah, that would be. Yeah, that would be better, wouldn't it? So, and that's to work with some of the fonts and so forth that are more than just the ANSI type fonts. And so if we're all working in that 16-bit bit character, it works. So we're just going to go ahead and change this, and you can put anything in between these double quotes you want. You can put your name in there. My driver, my driver's the best driver in the world. This is just using the example here of something other than what the driver wizard gave it as a default. If you look on that file, you can see where the two component name protocols are. You got the component name, it does the ENG version, and below that, it does the component name 2 protocol, which is the 2x2 version, or the EN part of that for English. And if you had multiple languages, you would update those two particular data structures for supporting multiple languages. So go ahead and save that. And now we're just going to go ahead and compile it again and do the build run. We want to go to the file system, load our driver, type in drivers, and what we want to see now for this time around is we want to see that it has that name when we do drivers. I'm just going to do this real quick. And at the end, mine's coming up at 77 this time. And then just reset. And we'll look at the next thing to port. It'll get a little bit more difficult now, because what we're going to do next is port the supported function and the start functions. Now we only have like 40 more minutes here. So we're going to just take a look and see how we do this and how we do this supported and what we might need to do in the start. But if you were going to really port it, you would actually be looking at a particular type of hardware that you can do, like a SCSI or some kind of USB maybe. Then you want to follow those particular protocols according to the UEFI spec. For today, we're going to do our supported. So go ahead and open up mywizarddriver.c in your Visual Studio. And scroll down till you get to the supported function, and you'll see right now that it just has return unsupported. So every time it gets called, and if you add actually debug code in here, you're going to see that it calls this function every single time it does something. So you want to make this very small. So what you want to do is, okay, the controller that's passed to me, do I support it or not? Exit. And that's all you want to do. So, we're gonna kind of do some tricks here and say we're going to support something, so we get the idea of how it works. So we're going to copy instead of we're going to comment this out. So just put a couple of slashes in front of it, and if you're following in the doc here, you can go ahead and copy this section of code and paste it into your supported section. Down. Save the file. So save it, but we're going to add some more things to it here, because we're not done. Because we're going to port the start too. What we're going to do, if we take a look at that code, maybe I should put this up here. What we did, and this is probably easier to look at. What we're going to say is we're going to do something with a serial port here. So say we're going to do some kind of serial port we're going to manage. So we're going to take a look and see if that controller is part of the serial port. And if it is, we're going to return supported. Return EFI success, which is supported. Otherwise, it will return some sort of error status. It wasn't the correct one, or it never found the serial port. In the case of my laptop, I don't even have a serial port anymore on this laptop, so it's never going to find it. So we got a trick to play with that. On your workstations, it will work though. So I tested it yesterday, so you will have it support this. So that's good. And if it does find it, it just closes. So you can see it here, open protocol. Yes, you found it. And then close protocol. Return success. That's our supported. Simply see if that's going to support that. If it does, say, yes, I support it. Close that protocol that it's going to use. So that's all the supported needs to do. So it just needs to be quick and short. So we said we're going to look at the serial port, so we need to add the serial port to our H file. So you want to open up your mywizarddriver.h file. And somewhere in the list of includes, also put and this is showing right underneath the PCI-IO, because that's one of the ones that gets consumed too. We're going to also include this one. So again, you can copy that and paste that into your consumed protocols. And save that. So we're just adding that. Now, since we're going to use that serial, we need to reference it, and we're referencing it in the INF. Otherwise, we're going to get a build error, because it won't find that protocol. So what we're going to do is add that to our my wizard INF file. So again, I'm going to go ahead and open up my INF file and put that in my list of protocols. And you can just put it at the end. As it shows here in your list of protocols in your INF. So we got a reference to that. This is the, and just incidentally, any time you have a lowercase g in the EDK2 source base means it's a global. So somewhere in an H file, it gets defined. On the other hand, if you see a M, it's global for a module. So if it's a lowercase m, and you see this a lot in this shell code, because it means it's local to that module, which means if I'm including that module, I have access to it. And you can do this with your code too. If you're writing a driver and you have like a local global for your module only, you can do a lowercase m for it. And you'll see that notation if you look at the EDK2 source base. I just thought I'd bring that out when we're talking about that. Okay, so we're including our GUID for serial I/O. So go ahead and save that INF. Now in our H file, we have our list of libraries, and just review it. And you'll notice the wizard kind of said, oh, we're probably going to use things like UEFI boot services. So it actually included it for you. You're probably going to have some debug code, or eventually we want to add debug code. Maybe we're going to do some debugging, and I'll show that here later on in the lab. So we include the debug lib. So it assumed that for your template, you probably want to use this just in writing a general driver, a UEFI driver. So it included some of those. So save and close the .h. Yes. And then after including the driver, we want to add. So when you look in the driver, mywizarddriver.c file, there's a couple of lines we're going to include. Okay. Okay, yeah, because we're going to put this in our start. That's why. So this is going to be copy. And I'm going to put this in my driver C at the top, just below the include for my driver.h file. And save that. And now we want to look at the start. So now we ported the start, supported. Now let's look at the start. Now the start, if we were actually going to do code in this, we would probably create a child handle and maybe install another protocol depending on what we're managing. Today we're just going to fill a buffer to see that it works. So we're that's why it's called dummy buffer. Like I said, this is a 2-hour class, not a week-long porting and coding session. So go ahead and copy that into your mywizarddriver.c underneath the start function. So scroll and find the start function. And right now your start function just has a return of unsupported. So comment out that line and then insert this code here. And do I have a, okay, yeah, here. So what it's going to be is now you have your driver binding start function. And what it's going to do is it's just going to fill a buffer. And we got to the start because we got our supported worked. And so we're just going to see that we got here. And so we're just going to fill a buffer here. And then we're going to check to see if that buffer got filled. So that's why it's called dummy buffer and so forth. We're not going to really do a whole lot here with this start. But this is where you would do your install protocol, install handle, create a child handle, and create, like if you were doing something with a serial port, you would set up your baud rate and so forth. You can look at a couple of other drivers to see what they did. You can look at the SCSI driver to see what it's doing for real at the start. So we said we wanted to do some debug. So let's go ahead and add some debugs here in our driver. So we're going to do this debug statement. And what we want to do is if we don't find the serial I/O, if you're like on my laptop, I'm never going to find it. So I want to have a debug statement if it doesn't find it, so I can see if it really works or not. So I'm going to go ahead and copy that in my C code here in the supported, where it does that return error. So if you scroll back up to your supported function, and right there on the error code, that's after it looked for the serial I/O protocol. Doesn't find it because it's on my laptop. I don't have a serial port, so it's not going to find it in our NT32 emulation. So I'm never going to get beyond this if statement for my laptop. You will have it work on your workstation. So I'm going to put a code in there and insert that debug statement. Then if we do get supported, let's say we do happen to have a serial port, let's say we say supported, so we say success. So we'll have a debug statement for a success. So if it does support it, we're going to close the protocol, and then before we return, we'll just have a debug statement there for returning success. So I'm going to add that at the end of that. Then likewise, if we are supported, we said supported equals UEFI status success. In our start, we're going to have a debug statement. Yeah, we're going to do our start now. So if you were really creating protocols and installing child handles, I might want more debug code in that point. So I'm going to add this debug code here right after my set memory buffer here. So just copying that. And paste that into your start function right after, oh boy, that already got put there. You might already have that there if you copied the other buffer. So it's right after the set mem 16. Okay, so let's go ahead and save our C file. So save that. And now we're going to test it. So we're going to go back to our Visual Studio command prompt. Do our build again. And then follow that with a build run. So I'm actually going to show this here. So now it's going to be important. And you guys are going to actually see a little bit different than on mine. So I'll show you, because mine's on my laptop. Let's see. Okay, yeah, I can see it here. So I'm going to load my driver. Now watch the window on the left here real carefully. Yours is going to be a little bit different. I've got a bunch of not supported, because my laptop doesn't have serial port. Remember, we're looking for the serial port protocol. Didn't find it. Huh? I got the exact same. You got the exact same. Uh-oh. What's that? I tested it yesterday on this station, and it has serial port. Okay. 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 All right. So if you didn't have that, okay, we're going to do the next lab. Okay. So, yeah, if you had a serial port, yeah, it would be supported. But you also see that every time it went to that debug, it got called, and we said unsupported, unsupported, unsupported. ID drivers. And we still have our driver in there. Still 77. Okay, so we didn't have a serial port. So if we go on to the next section, so everybody got like this. Is there anybody that got something other than this? You did? You got a supported somewhere in the list. Okay. Anybody else get a supported? Okay. Some people did. Okay. So if you got a supported, that means it had a serial port on it, and then in your start you could manage that. Well, if you didn't get supported, we're going to do something different, and this kind of leads up to our lab for tomorrow as well. So that's why we're going to do it in here. So for now, reset, and we'll go on to the next lab. You can do this in the ones that did show up too, just to see, because this is going to show you how to set up for NVRAM variables. So we're going to play another trick, but this is going to show you how to do NVRAM variables as well, so kind of keep that in mind. What we're going to do is we're going to create another file. So you can pull up Notepad, and you can copy this text into a file, and we're going to call it mywizarddriver nvdatastructure.h. So we've got this. I'm just going to copy, and I'm going to paste that into. I'm just going to paste it into Notepad because that's the easiest thing, and then save that into my C:, FW, EDK2, mywizarddriver with this name here. So I'm going to copy that too. So the minimal amount of typing I have to do. So a couple of things about this file. What we're doing is, and the reason why we want to do it in a completely different file is we're going to set this up to be an NVRAM variable. So there's a couple things about it. We have the pragma statements before and after to tightly pack it. We're setting up for a string data, a hex value, some sort of base address, enable, disable kind of switch. This is going to be a tightly packed something that's going to actually exist in our NVRAM data. And anytime you have some kind of variable, you got to define some sort of GUID. So we have a GUID definition. Anything we want to reference it, we're going to give it this GUID to reference it. So you'll see it tomorrow if you come in and do the HII data. We're actually going to reference that same GUID of where this data structure is going to be and manipulate it. So today we're just going to create it, and you'll see that we're creating it. And by creating it, we're also going to say success unsupported. So that's the idea here. So save that file. So we actually have a new file. We need to include that someplace. So we're going to include this in our other H file. So save it. Open our C file. Copy and paste. So our H file, we're going to copy C file. So copy this text, and we want to put this in our C file right after the mywizard.h. So if you look at your C file, at the very top, you're going to have an include of the H file. So you're going to include this, and I will tell you what this is doing here. So what we have is we've got to have a variable. Now, what we're going to see is if we look at this variable with our shell, we can see that variable. It's going to be this type that we created in our H file that we just created. We created a type def with this type def. So that's what we're creating. And remember I said something about the m, lowercase m. So this is a global to my module. This is going to be a global to my module, my UEFI driver. So I'm going to reference it anywhere in my UEFI driver. So that's what that's going to do. And then we're just setting up a buffer here in this next one. And then we're calling out the GUID that we just created from the H file that we created. So go ahead and put that in there then. Now, since some of you didn't get the serial port, so what we're going to do is we're going to fake it. So there's going to be a fake supported that we're going to create here. So we're going to comment this out. And we're going to make a call to this fake supported routine that we're going to create. I'm going to copy that. And comment out the debug and the return statement. Now I need to add this function call that I just called out here. So it's going to look like this, where we comment out that. So it can be right after the if statement. We're going to call fake supported, and we're just going to return whatever that returns for us. So our fake supported, so we want to copy this function. And the best place to put it is right before the supported, because in C you want to have it declared before. So put it before it's called out. So you've got this fake supported. I'm just going to copy this code and put it before my supported function. And it's going to be after our entry point function. So, and you see it's just called fake supported. Doesn't have any parameters passed to it. And what we're doing in this, so what is this doing? So our fake supported, we're doing a get variable. So we go out, get variable. It's a runtime services. Go and get me this variable. We're giving it the variable name. So that's the name that's global to my function here. With this GUID, that's a GUID we created. And then give me the buffer for it. So give me the contents of that variable. So that's what it's doing. If it's not there, we're going to get a status, a return status of not found. So if it didn't get created, it will then create that with a set variable. So here we're doing a set variable with the GUID, the variable name we want to call it, and we're making it a non-volatile, and it's a boot services variable. And then just the size and the data structure will pass to it. And then if it does do this, we're saying we're going to take this out to be our supported by creating this NVRAM variable. So that's what our fake supported is going to do for us. Now we're not done yet, so we go ahead and save our C file. We're done with the C file. we need to include that data structure in our H file. So what we want to do is include, I'm sorry, I have a couple of things we need to do. One thing, for the variable services, we're making a call to runtime services, so we need to include that in our H file here. Debug lib. So put it after the debug lib, include of the debug lib, as it shows there. It doesn't matter where it gets put, but just make sure that you include it in your H file. And then we need to add and include for our new H file here. And you can include this anywhere as well, but it's saying to include it after the simple text, just to kind of make it structurally the same. So I'm going to copy my wizard driver nv data structure.h here, and I'm going to include that sort of towards the end of the includes. And then we save that. So we've got that right there. That got included. Now we're ready to build and run it again. Everything got saved. We have to go ahead and build. Oh, it did. Thank you. Okay. So mine built okay. I'm going to go ahead and test it. So again, I'm going to put my window. Yeah, I see that. And put one of the windows here so you can see what happens. I'm going to do F0, load my driver wizard. And what you see now is success with the fake supported call with the NVRAM variable that we declared. So we kind of faked it out. This shows you some other things you can do rather than doing some other protocol or whatever. And then when it did the start, the buffer that got stored is right here at 4F21010. So now I'm not going to do drivers. I'm going to do mem 4F210. And there is the buffer that got stored in our start function. Okay, so that's what we want to show for that. A little bit about the debug, a little bit about doing NVRAM variables. We see our buffer with a mem command, with a shell mem command. Yeah. And type in reset. Any questions so far? Okay. Then one more thing we have to do is the stop and the unload. So when part of that, so if you were doing the unload and the stop, if you installed protocols and installed handles, you want to uninstall. So you want to mirror what you do in your start. In our start, we allocated memory, so we want to actually free memory in our start. In our stop, in our unload. So that's actually what we're going to do. We're going to do free pool. So look at your my wizard driver C file again. And go down to the stop I'm sorry, it's doing the unload first. I see. So go down to the unload, which should be at the start of the file. Entry point. So, and the unload is a little tricky because there's a bunch of code going on because it's doing some uninstalls as it is. But what we want to do is put this at the end. So I'm going to go ahead and copy and put that right before the return in our unload. Where it says do an additional cleanup that this driver requires. So this is where you would do a uninstall and so forth. So we go ahead and add that. Then additionally, we're going to do something in the stop. So we're going to add code in the stop. So pretty much the same thing. We're going to free pool. And we're going to copy that into the stop, which should be towards the bottom of your file, your C file. So comment out the return unsupported and add the free buffer code. And let's go ahead and test that code out. We issue the build. Run. We're going to load our driver, see the location, and then we're going to do the unload. Actually, I'm just going to do it here. 0. Mine ended up at a different space, 528.10.10. And then we what we want to see there is unload and clear buffer, unload success. So you should see that when you unload your driver. And if you did drivers again, it should be unloaded. And that's actually going to bring us up to looking at HII for tomorrow. Any questions? If we were to look at our HII, if you're going to be in that tomorrow, let me do a build again. And I want to show you the, since we got a couple more minutes of time here. Okay, so we got our driver. We got debug commands coming on. So if you're writing more code, you can add insert debug commands and see them out. You can also play with Visual Studio, the debugger in the Visual Studio, by doing a CPU breakpoint, and it'll pull up the Visual Studio 2, and you can start debugging at that point. But what I wanted to show here was FS0. I'm going to load my wizard driver. Okay. Now remember we set up a variable, NVRAM variable, and I want to see what that is. So I can do a dump store. So that's a shell command, dump store, and we're using the shell too. So I'm going to do -all, and it's just so going to happen because I loaded it at the end that I get my variable here. My WD, that's the same one we did in our code. We get that variable showing up here. If we want to look at for tomorrow, what we're going to look at, we set up a sample form set here. So we've got the start of our HII. Right now, there's nothing in it. So tomorrow, we're actually going to take this and add to this form. So we can add questions. We can actually update that data store that I showed you, the NVRAM data. We can update it using our HII, and that's what we're going to look at further tomorrow. Now, if I exit, reset. What I want to show you is we set that up to be a real NVRAM area. So now if I just follow that with a build run. So I didn't do a build in between. I still got the NVRAM variable out there, even though I haven't loaded the driver. Oh. I'm going to do a dump store. I'm going to do a break because now I don't know where that variable is going to be. And so we should see this in our list of NVRAM variables here. No, that's the wrong one. UEFI variable. Here we go. So here's our variable again. So it's actually stored in NVRAM variable, or NVRAM space. But right now it's just set to 0. Tomorrow we're going to show how to update that using HII. Okay, any other questions? There's other labs in this guide. You can use the lab if you want to take it home. Take that zip file, unzip it, and you can go through that lab guide and see the shell labs. There's a lab on writing a UEFI application as well. So it goes through some of the steps, so it will all work with that same lab material. So that's it. Thank you.